This is the Amp Hour Podcast, released April 23rd, 2023. Episode 629. At least my house isn't haunted.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics in the Riddler department. No, Puzzler. Damn it, I got it wrong again. Riddle me this, Dave.
Yeah, okay. Yep. Apparently last
Puzzler
week, which I have
department.
not listened to.
That's
so,
right. That's right. So we're gonna do it.
There was some.
Well, I'm going to do a recap here, and then Dave's going to be able to guess live, and everybody else will be able to find out what's going on here.
Is this like a real thing? That this is like a real thing? It's not like a made up puzzle, right?
That's right. It's a real thing.
Right.
Yeah. I'm not that good. You know, I can't make up this
Okay.
kind of stuff. But it was actually it was freaking me out. That's probably the main thing.
Okay.
All right. So as a recap, I'm sitting at my desk where I am now, and it's like the middle of the day, and it was like a Monday, and my main monitor shut off.
There's your problem right there.
I was sitting at the desk. Oh, Mondays.
Yeah. Monday.
Yeah.
Monday's problem. Yeah.
And so I'm like checking I look around and all my power's off. And then I looked at the router's turned off, everything. Basically my whole office is dead.
Yep.
I'm like, okay. I go out to the hallway, and the hallway light is still on. And the bathroom light next to my office, the light's on. I'm like, okay. And then start going through the rest of the house. My daughter's room turned off. It's off. I can't switch on anything in there. And then my wife's office is off.
All right.
And many of the other things in the house are fine, but I'm like, all right, I'll go check the breaker. What's going on here?
Yeah.
So go down to the breaker, check the breaker, nothing's flipped. Okay.
Yep.
So start flipping some breakers. Nothing seems to come back upstairs. Light's still off. Nothing changed. But like the garage door had been kind of pokey the past couple of days. Like it had been like kind of like finicky. Like I thought it might have been the sensor or something like that. But like it was like kind of going up a little bit slower. But then also like just this weird stuff happened. So I'm like, I wonder if it's like the GFCI in the garage. And so I hit the test
button. Yep.
On the test button on the GFCI. And I should mention, because I told this to a friend in Europe, the GFCIs are in the wall here. Many places they're in the breaker box.
Yes.
Only.
That's what they're like here usually.
Yeah, and they're actually both. So my breaker, some of my breakers also have GFCI in them. They have like the test and this reset. But then I also have GFCIs in the wall. That is not relevant to this story. I thought it might have been interacting, but I go to hit the test, it pops. I can hear it pop, and then I go to hit reset, and it won't reset.
Yeah.
The one on the wall. I'm like, what the heck is going on here? This is so weird. So then I'm like, maybe it's other GFCI. I thought it was like maybe interacting. I don't know. So I like go around the rest of the house. I'm going to the kitchen has some, bathrooms have them. And then finally I go upstairs to the bathroom upstairs, the bathroom near my office. I test and reset it. And then like things seem to be okay. I'm able to turn lights back on in my office. I'm like, it must have been some kind of, really weird, right? So that's on Monday. On Tuesday evening, it happens again. And and everything's like dead at this point. I can't figure it out. I have no idea what's going on. And I'm trying to remember what I said in the last story too. So at that point, I'm like, all right, I'm calling an electrician tomorrow morning. And the rest of that night, I just didn't have power. And I was like, I tried everything again. I flipped all the breakers, whatever. Yeah. And I just could not get anything to go.
So, but just power, you still had lights, right?
In certain rooms, I had lights. Mm-hmm. So many of the rooms I had lights, not my office and not one of the other rooms. And then my wife's office, it did have lights, but like I went to go we have ceiling fans too. And I turned on the ceiling fan. The ceiling fan's like super slow. It's like spinning up super slow. Cause it's just, I'm just like, what the hell is going on? I was like really getting freaked out. And so then I had company coming. So I started like, all right, well, nothing's working here. I still have to clean this room because I had company coming. And so I go to turn on the vacuum cleaner. And I plugged in like the vacuum cleaner, and the lights dropped out. And I'm like, my house is haunted.
Right. Yeah.
Okay. So I think I actually don't think I shared that. May have given you a little bit more info than the last set of folks.
Okay.
Than the last episode.
Well, yeah.
So what do you think maybe
Well,
this
when
is.
you turn on a large load like that and other stuff dips, that indicates some sort of high impedance. So I'm thinking some sort of intermittent high impedance, neutral or something like that, perhaps. But you
Mm-hmm.
guys, you Yanks, have this weird split phase thing, right?
Mm-hmm. Yep.
Yeah, you people think the US is 110 volts. It's not. It's actually 240 volts. It's just that you guys do the weird split thing when it gets to the house or something.
Mm-hmm.
So that complicates things. So I'm not necessarily familiar with that, but my money would be on, some sort of intermittent, neutral or even a intermittent active feed or something like that, like a high impedance. The screw terminals, it's all pitted, or it's, I don't know, the incoming
Okay.
connection is pitted and you don't have the impedance. I don't know. Sounds weird.
Yeah, it was super weird. So it was super weird.
I think I'm totally wrong, but that's probably the only thing I could guess.
Okay, so here comes. So if you well, I guess at this point, all of the entries are closed. Nobody actually got it by email either. So
Oh, okay, right, yeah, right.
at least as of this recording, so we're recording on Thursday. I'm not going to close entries until Sunday when we actually publish this thing. But as of this recording, nobody got it. If anyone does, by the time we record,
and I obviously haven't got it. Otherwise,
sorry, you did.
Am
Well,
I
also
similar?
it's the prize is a T-shirt, so you probably
right.
you already got there.
So did I guess similar to the other entries?
Most people keyed in on the GFCI stuff.
Right.
So they thought it was maybe, let me pull it up here. So
yeah, but they're usually like circuit based. They're usually like for individual radial circuits, right? So usually if folding one of those won't upset the other ones. If you've got a rock solid ground, if you've got a rock solid incoming connection.
Right. And that's what I was thought too. And so like, that's why I was weirded out about it, because there's really no reason that a GFCI on a one breaker should really ever impact another breaker, right? I mean, because as far as I understand it,
is there like a master one for the whole? No? Okay,
no.
Right. Yeah.
All right. So some of the other guesses were daisy chain GFCI, loose breaker on the bus bar, loose wires in the screw terminal, arcing that occurred in the faulty garage opener, open neutral in the box, dead rodent in the back of your PowerPoint.
Yep.
That sounds like personal experience.
But that usually will only impact one radial, right?
Yeah.
Circuit.
Yeah, exactly. Yeah, they wouldn't like feed back. And this is
why
you
guys use radial, not circular, right?
Sorry, what are you saying? Radial versus circular?
Radial means you have your one incoming point, and then you have one branch circuit which radiates out like spokes on a bike, right? So it doesn't loop back. So it's actually called a radial here. It's called a radial connection, but you can actually loop a connection. So you can actually loop from your circuit box through various rooms and then loop back, so that if you get a break in the cable, it would go in both. It would just go in different directions. I'm not sure under what circumstances.
Yeah, no, we're one way. So
okay, well, you're using what's called a radial. Yep.
Okay, in a radial, yeah. So basically, it's like if you think about it, like if you were wiring from the circuit box, at least this is how I understand it, which may be broken.
Yeah.
It would be like if you had a circuit that was coming up to my office, for example, and I had 4 power points in my office. If you think about the farthest one is the end of that connection, and then there's like kind of 3 others that would be basically spliced in along the way. That's the easy way to think about it.
That's called a radial. Yes,
that's a radial. Yes. Okay, cool. All right, other ones.
All right.
Another loose wire or breaker box.
Yep.
And then faulty neutral question between your house's breaker and the transformer. Okay.
There's not anything electromagnetic near your fuse box, is there?
Nope. It's my fuse box is in the garage.
Okay, so you haven't introduced
nothing new.
Anything new.
And this is like it was like out of the blue, right? It was just completely out of the blue. And this is why. And so I had said in the last episode, so I recorded with my other friend Dave, and I said I kind of figured it out, and he stopped me. He's like, "No, you didn't. That's no, the electrician figured it out." Okay, so I'm going to tell you what happened, and then maybe so you didn't get it, just so we're clear. But I'm going to tell you the thing that happened that may clue you in. And I knew this is when things got really weird. Okay, so at this point, I'm hopeless, right? I'm just flipping breakers, right? I'm just flipping breakers, flipping breakers.
That'd be me too. Yeah.
I had work done on my air conditioning unit, and so they installed a new cap across there. And I'm like, is it possible that he shorted something when he was doing that? Is that possible? That's so weird, right? That's not something that would happen. And so I'm like, I'm flipping every breaker. I'm like, all right, I'm going to flip the breaker out to the air conditioning unit or the HVAC. So I flip it, nothing happens. And I'm like, all right, fine. And I have an electric water heater, and I flip that, and the door into my house from the garage was open, and all the lights in the kitchen were on, and the lights went off.
Oh.
And I'm like, what the hell? And then I go inside, and I notice the living room lights are off. I'm like, what the hell is happening right now?
Because you disconnected an element load.
Okay, explain that more.
You disconnected your hot water, right?
I disconnected my hot water. That's right.
Right, which is an element, right? Which
That's
is
right.
a high,
It's a resistive heating element. That's right.
Yes,
That's right. All right, let me just keep going from here. This is because I had no idea. I knew that was something weird, but this is the most freaked out I was. Some people are probably listening right now. They probably get it. And this is probably where the US thing really matters. All right, so the electrician shows up.
I suspect it's a US thing. I suspect
it's
it would not happen
this
here.
Is,
yeah,
this is a US thing.
That's why I mentioned this weird split phase American thing at the start, because I suspect it has something to do with that.
Mm-hmm. Yeah. Okay, so the electrician shows up. I show him the box. We're in my garage. He's looking at it. He's like, I don't know. That's kind of weird. And he's like, all right, well, it's not here. Let's go outside. And it's like really bright outside that day. And like the sun is like beaming down 45-degree angle right onto my power meter outside.
Yep.
And he goes outside and he calls me out. He's like, hey man, can you see this? And I walk outside and it's like super bright. I'm shielding my eyes. I'm like, no, I can't see it. He's like, yeah, it's not there. And I'm like, what? He's like, no, you can't see it because it's not there. I'm like, what is going on? He's like, you don't have power at your meter. I'm like, yes, I do. My house is lit up. He's like, well, as luck would have it, one of the phases powers the display and the other one just goes into the house. And that's how he knew that I didn't have power on one of the phases into my house.
So it was capacitively coupled, was it, into your house?
No. Okay, so like you said, Dave is right. There's 240 across two of the legs, right? But it's split in the middle. So it's 120 to the neutral. From leg 1 to neutral, it's 120. And then from leg 2 to neutral, it's 120. So if you go from leg 2 to leg 1, it's 240. And if you look at the breaker that goes to my hot water heater, really any resistive heating element in the house, it always goes across both.
Yep.
It goes across 240.
So yes, you guys don't have 120 volt appliance like hot water systems. You've got 240 volt hot water systems, right?
And some motor systems as well, right? Yeah. So basically it's like a different type of plug and whatever. So like my HVAC is across is a 240. My dryer, I have an electric dryer for my clothes. That's 240. The hot water heater 240.
Right. Yep.
Okay. So now the really crazy thing. So my garage door, when it was going really super, super, super pokey, it was on a bad circuit. There was no power on that circuit.
Right.
So when my garage door was going up and when the vacuum was going on, power was going from leg 1 through the resistive heating element of my hot water heater to leg 2.
Oh, that's
crazy?
Fantastic. That's
Isn't that
fantastic.
Crazy?
Yeah.
So crazy. I was just like,
that's
oh my
fantastic.
God, everything makes sense now. My house isn't haunted.
Yeah, because I mentioned capacitive coupling, but I went, I was thinking, no, it can't be because you're just not going to get the power available. Yeah. But going through a resistive element, that makes total sense.
Yeah. And he said, I've seen this before. I've seen it go through people's electric stove elements.
Yeah, right.
But that only works if the stove is turned on. So the other thing that happened was because I had used hot water in my house, there's a thermostat on there and it turns itself off when it doesn't need to be heating anymore. Yep. Well, I had used up a bunch of the hot water because I didn't know that this was happening. So I had been like using hot water. I'm like, oh, it's getting kind of cold, but it's not like, it wasn't like cold yet. And it was still actually heating water on the one active leg that was there. Right. So it was heating at 120, but it was pretty much always on because it was just racing to keep up with the 120 heating element. And so in that case, it's basically quote unquote always on. And so it's always passing power through that resistive element to the other leg.
I was kind of sort of right that it was going through a high impedance or some sort of, when you're talking about an element, which might be 10 ohms or something, that's high impedance. In terms of
like a vacuum cleaner pulls, or any kind of motor
is going to draw
pulling 10 amps, right? And it's just like a 10, huge thing. Amps, and that's why it didn't make any sense to me that there was this huge drop.
Wow. Yeah.
Yeah. So crazy. And I was
it was a broken neutral connection, was it?
No, it was a broken hot connection. One of the legs was hot. So neutral was still there. Leg 1 was there. Leg 2 was broken. Or whatever.
Right.
You know, one, it doesn't matter which one.
Yeah.
So that's also why in my house, every other room basically was off, right? It was basically because if you look on the back of a panel, it's a zigzag. So every other breaker is on either leg. And so it's those double breakers that are across both legs.
Right. And these symptoms would have changed depending on whether or not your hot water element was switched on.
Yep, exactly. Yep.
No.
Okay. So
wow.
He's like, all right, well, that's $200.
yeah, of course.
Took him about 5 minutes. He was great.
Yeah.
I mean, I'm like, you know what?
Yeah, no, totally.
Better than I did. Better than I did.
Because he's seen something like that before. If you haven't seen something like that before,
I mean, he's also just checked, like, of course he's going to go check the meter. That's what he always does, right? And like,
of course.
So he's like, yeah, you got to call the power company. And I called the power company. They're like, we'll send someone out.
So the meter, so you've got one of these newfangled electronic meters, do you? So you could see that it was on?
Yeah, the display. I mean, like the old analog meters. So you could see
that your house was getting power, right?
Yeah, that's right. That's right. Yeah, I should have gone out there. I mean, honestly, that's a bit irresponsible of me. But like, I had power in the house, right? It seemed like I had power in the house. Why would I go out there? It doesn't make any sense.
Yeah, of course. That's great.
Okay, so I called the power company, and they'd been doing work out on, you know, so between the Monday and the Wednesday that I called, basically, you know, I'm just like questioning everything. I'm like, yeah, you know, they were out on the pole. They've been doing some work. I saw like a bucket truck out there that was doing some work on the pole. Right. And then there was this big bundle of cables and this big black looking thing that looked like a big capacitor out there. And I'm like, I bet they messed with something. I bet they're like doing load tests. I'm just coming up with all these theories. Finally, I look up like black cylinder wires, you know, power pole or whatever, and it's a friggin' splice for cable for fiber optics. You know, I was so far off, it's not even funny. Yeah, you know. So I don't know how power stuff works apparently. And also, why they would not put anything that's like live power on the ground, right? It's like
of course.
So not the brightest.
That cannot physically happen here. The only way something similar could happen is if you get a break. In an active brake, you'll have capacitive coupling. So some LED lights might still work, for example, and that's actually a common thing. In fact, some LED lights, did I do a video on this? Or I was going to. Like the modern LED lights operate with so little current. They can operate with so little current that they will turn on and appear dim even if your switch is turned off. But just due to the capacitance in the switch and the wiring.
Wow, that's crazy.
So yeah. So
okay, so I was at least skeptical that, you know, something had been done on the pole. So I called the power company. The guy comes out. He looks at the pole. He's like, "No, man, that looks great."
No,
he's
that's
like,
good.
I'm gonna start digging. You know, like this guy is just, he's a lineman. He's like, I'm gonna start digging. I'm like, okay, yeah, that's great. He was awesome. Moved really fast. I got to send Dave a photo right now.
Oh, okay. So they were digging for nothing, were they?
They were digging for the right stuff. So basically, he tested power at the base of the pole, as you do.
Yep.
And then I think he turned stuff back on, and he has like a little detector that shows where there might be a break. He basically sensed where it was, and he started digging there. And he goes down about 3 feet or whatever it is, you know, about a meter here. And then he calls me out. He's like, "Hey, found the problem." And you know, power came back on in the meantime, so I had power again. I knew it was back on. And he showed me what I'm about to show Dave.
You can actually get dedicated tools to check the impedance of systems like
interesting.
This. So, I'm not sure how they work in the US, but yeah. Oh, there we go. Let's have a look. Oh, not found.
All right, so paint a little audio picture here.
It doesn't work. Oh. I get a 404 error.
Oh, interesting. Okay. Let me try again.
You're using Photos Google.
Yeah.
Googly photos.
Actually, I'll send it on our chat, our other chat.
Yep.
Okay. So
copy it and paste.
He hands me two things. One looks like a shell, a black shell, and like a cylindrical cell.
It looks it looks like a bit of burnt wood, like a burnt tree branch.
Yeah. Okay.
Kind of thing.
That's right. Yeah, like a hollowed out tree branch. That's a good thing.
Yeah.
And then what's the other thing?
The other thing looks like some sort of clay brick or something.
Yeah, nice. Square rock, I'd say. Yeah,
square rock, something.
All right, here's what happened. When they backfilled when they put your power in, they backfilled with fill, like clean, ostensibly clean fill. The square thing is a rock, and it was on top of your cable. And what happens over time is that it kind of because of just natural vibrations and settling in the ground, it works its way down and it works its way down. And sometimes it's right on top of a cable and it works its way down through the insulation on the cable.
Really?
And then the cable says, ooh, look, pat the ground. And it blew itself to pieces. So the white stuff, I'll post this photo obviously in the show.
Yeah.
The white stuff in that tree looking thing. So this is actually the shell. This is the insulation of the shell.
Yeah.
The white stuff is aluminum oxide. It's an aluminum cable. It blew itself. It oxidized itself to death. And that thing used to be a solid conductor. It is now dead to the world.
I can see the twist in the aluminium. No, this aluminum rubbish. You can see the twist in the aluminium.
You almost said it.
Yeah. For those who don't know, power lines use aluminium wires because for weight.
Right. Because copper is expensive as hell too, right?
And it's expensive and it's heavy.
Yeah.
So they actually, Yep.
Yeah. And so that's what did me in. Single conductor, one of the legs of my powerhouse to my house blew itself apart. The guy was telling me lots of crazy stories. I asked him to be on the show. He's checking. I don't know if he'll be able to because he works for the power company.
Hang on. So what have you got coming into your house? Have you got 3-phase?
They have two-phase.
Oh, so, 2-phase. Okay. Right.
So there's a 2 hots, a neutral, and then there's a local ground thing, right? There's like a stake that goes down into the ground, basically.
Yes, yeah.
And then it's tied to that.
It's actually a physical ground. You guys are so weird compared to ours. You've either got single phase or you got 3-phase. So
technically it's 2 single phases, but yeah. What do you have coming into your house?
We've only got a single phase, so there's only 2
single
wires
phase,
coming into our house. Yep, single phase at 240, and then every second house goes across a different phase or whatever, just to sort of balance out the grid. Yep.
Huh.
So
makes sense.
Wow. Yeah. So our street usually, I'm not going to say no. Definitely not in all cases.
So is it possible every other house in your street could go out? Is that possible?
That's actually possible. Yes, it could.
Interesting.
I think.
I mean,
I don't know. Leave it in the comments.
Do you know any power engineers in Australia? That'd be really just like the differences. Europe, Australia, US, everywhere. Like these all have their weird idiosyncrasies, but like
but you guys have the same 3-phase system as us. You just implement it different at the point of load.
Okay.
I think. I do believe, like, if you go look
Dave,
at your overhead lines...
I'm very obviously out of my element.
Yeah, but if you go out to the street, right, and you have a look at the big power poles that are 11 kV or something like that, you're going to have 3 wires, right?
Yeah.
You're actually going to have 3. That's actually 3-phase. And then, every maybe every alternate street goes across a phase, so you could have a street that's technically out. I don't know if every second house is like... on or every third house is on a different phase. I'm not actually sure, but we just have a single phase actually coming in, and
that's great.
Yeah, just 2 wires. So this problem is physically impossible to happen here.
Right, your whole house would just go.
We would, the whole house would just be out. Yeah, wow, that is weird. That is great.
It is so weird. Yeah. I excitedly called my father once it figured out. I was like, I am both relieved and excited. One, I'm relieved because I have power back and I know my house is not like playing tricks on me anymore. And 2, I'm excited because I get to talk about this on the Amp Hour.
You've got half an hour worth of content on the Amp Hour. Right. Yes. Because that is weird. I've had like weird stuff, happen like that. And I go like, wow, how can that possibly happen? Like it's such a rare thing, and it happens to me, and and I can actually blog about it, Yeah. And it's like,
So the lineman guy said if the neutral goes out, that bad. Because basically then you have 2 hot phases and they got nowhere to go. And so where they go is basically the ground connection. And if that doesn't work well, then they go wherever the hell they want to go.
Right.
And he said he once saw aluminum siding or aluminium siding that was actually energized. He said he met someone who once had, every time he was afraid to use his bathroom at night because every time he would get shocked because it was like tied to the pipes, And so like actually, and he said grounding before they used to do this.
Oh no,
the stake grounding, they would actually tie it to like a water pipe because that also goes to ground.
Yes, of course, water pipes go underground. Yeah. Wow,
it's nuts. Yeah. And so anyways, like I said, I asked him to be on the show. I don't think he's going to be able to, but he was great. Regaled me with some fun stories that I cannot repeat here.
That's great.
I just think generally, like, I'd love to get alignment on here generally. I mean,
Yeah,
so
that'd be
if other
great.
people
Yeah.
have an insight to someone, so we had Paul Zawada on here. Paul
Yes.
was able to talk about some of the stuff, especially like the
Yeah.
kind of the architectural level stuff that he was working on. But man, weird stuff that can happen, and it's just like in our houses every day. So
yeah, no, it's
so we'll
crazy.
see if we have any other winners.
But yeah, it's remarkable how it happens to you. And I get these weird things happening to me all the time, like the test equipment curse. You know, what are the odds that I'd be the one to get a brand new Roden Schwartz oscilloscope that has a loose screw in it? And I shake it, and it's got a bloody loose screw in it. What are the odds, right? What are the odds that I'd get a new review product from like a new power supply, and it's got a capacitor that catches on fire? Right? I mean, what are the odds, right?
Yeah, I mean, maybe someone's like intercepting your mail and just like
they're sending me the dodgy stuff.
Maybe you're going to work and maybe you sleepwalk and you go to work and you just make things more interesting for videos.
Right. Yeah.
Can we tell? We don't. It's it's impossible.
Well, you wouldn't be able to tell. I've always thought about it. I thought like I could do a repair video where I could just take out like I could actually destroy an individual component. Then I could do a fake repair video and go through and actually find the fake component. I've always thought that would be possible and people wouldn't know.
This sounds like how like reality TV show happen. Reality TV, they're like, they like totally set stuff up, right? Because you need to have some kind of tension and then you have to have some kind of resolution.
I was watching the other night, the latest David Attenborough special.
Oh, okay.
Right. Sure. And they just get the most gorgeous shots of everything. Right.
Of course.
And I'm going, they're watching this avalanche happen and they've got like 5 different drone angles of this avalanche. And I went, no way they did not trigger that.
They didn't do that.
Right. They triggered that goddamn avalanche. They had to. I mean, there's no way you could have 5 drones
you're like sitting
ready
there waiting.
To go. Yeah. No,
the battery power.
It just doesn't happen. No.
Yeah,
it just doesn't happen, right?
They could probably tell like when it might have happened, but they probably triggered it.
No.
They said it was going to be for safety, but
and the drones are following the thing, and they got all the different angles, and it's like they triggered that bloody thing, and it's like and it's like and they're going to get in the gorgeous shot of this like a dead deer or something in the middle of this snow field. It's in the middle of absolute nowhere, and they just happen to be there when the animals that like the birds that are feeding on this thing just happen to come down. It's like, I don't know. Did they place the dead animal there, or did they find it and then went and placed it there so that I don't know.
And this is why I don't watch nature documentaries.
But certainly the avalanche. They've definitely triggered that bloody avalanche. I'm sure it was going to happen.
I do remember seeing one. I saw one where they were tracking a glacier that was like about to shear off, and they actually had sensors on it and stuff.
Right.
But then they said they were there for like a week just filming.
Oh, just waiting for it to happen. Yeah. Well, that's a bit harder. Like that's you can't just slice an entire glacier.
We're gonna need more TNT, guys.
Whereas I'm sure to trigger an avalanche is not hard. But
you spit in the right place.
Exactly.
System on the edge.
Yeah. Anyway.
Yep. I can say with confidence that I did not place that rock underneath the ground on top of my power 6 or 7 years ago.
I find that's absolutely because for those who don't know, your house is not old. Your house is what 5 years old or something, 5-6 years old.
6 years old. Dave mentioned that as well because you want to count out the spooky aspects of it all, right? Of just like crap wiring or whatever. I was really happy too. Like I was worried. Oh yeah. How about this? So at one point, everything had shut off, and then I'm like, I think it was like, my daughter was napping when this happened. My wife was working from home, and so was I, and the power was off, and then I start hearing this like buzzing coming from the walls, and I'm like, oh no. Like if this was like if you have to open a wall or something like that. Oh yeah, I'm just like, oh my god, what is that? And it was just like intermittent. It was like zzz, zzz, zzz.
Wow.
And I am getting so freaked out. And then luckily it was like as I was standing in the doorway to my office. Well, I have some speakers plugged in my electric piano that is in the background of my videos, but like I used it to play piano through there because they don't have speakers naturally. And it was plugged directly in the wall, and it was the power going through I don't know what it was in the amplifier. I think probably the amplifier was right on the edge, so it was like right at the top of the cycle. It was like just kind of like browning out or something like that, and it was just doing that buzz.
Wow.
And the same thing. The other same thing happened I turn the switch on to my bench, and
Yeah.
like the scope, one of my scopes that like has a fan, it was just I'm like, what? Yeah. So, anyways, we've got a half hour out of this. We can move on. Yeah,
I think that is great though, because that it's great to get started, because that rarely happens. Like that is, you know.
Yeah, I better friggin' hope so. It rarely happens. If it happens the other phase, I'm calling someone. Yeah.
Can't just move on just yet. And that makes me wonder: is there, like, because that's, it just disturbs me that's actually possible, right? In the US, right? It's not possible here, so you wouldn't worry about, you wouldn't care about it, right? But it's possible over there. So is there some sort of device you can install in your house that automatically trips everything if it detects a high impedance connection somewhere?
That's an interesting point. Yeah.
I bet you there's some device out there that'll do it.
That's so rare, though.
I know. Like, it's like,
it's not something to plan for, right? I mean,
exactly. It's something you wouldn't pay, a couple $100 for this device just in case this rare event happens. But I'm sure I
am a little worried about the lifetime of products that are in my house because of it, right? So
of course.
One, the heating element, right? I think power was passing through it. I think the thermostat would have shut off, right, if it gets above a certain temperature or whatever. So I think maybe not.
I think your hot water system would have your hot water system would have taken care of itself.
Yeah. I mean, I guess the one element was more stressed, is going to have a longer lifetime just because there's more power going through it for sure. And there was, at certain points there was more power going through, but it is kind of self-regulating. That is basically just a resistor. I mean, and it's in water.
Oh yeah, totally. It's just a resistor. That's why I thought high impedance path. You know?
And then the other one that was worrying, well, I think the garage door opener as well, just that it's all squeaky anyway. So I was just kind of worried about that. But the big one is actually the dishwasher was browning out, right? Yeah. It was getting to the top of its cycle, and it was just like, I could hear it like clicking. It was like click, 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 click. And then it would start back down again and spin back up and click, 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 click. Yeah.
This could potentially cause problems in filtering, in mains filter caps and stuff like that. Oh. Perhaps if things are like cycling, cycling at some rapid pace or something like that, could I don't know, potentially. Anyway, interesting. Wow, there you go. What else we got?
Well, things in my house didn't blow up, but one thing did blow up today, which is
the Starship.
The Starship.
Yes. Yeah. Well, blew up last night because I'm in Australia.
Oh, right. Well, I watched it in America where midnight. It happened. So
yeah. And my predicting penny. I have a predicting penny. You obviously didn't watch my live show, and I predicted that it would not succeed. So
yeah, I think most people didn't. I think it was really about where it blew up, not about if it blew up.
Well, I'm surprised, because while I was doing the live show, I went, once it's cleared that tower, I'm going, this thing's going to make it. And I haven't heard any aftermath stuff, but it seemed to be that something went wrong with the separation thing. And it would not, the Starship wouldn't separate from the super heavy booster thing. So I don't know, somebody forgot to pull the pin or something before there's some retaining pin or something.
Yeah. We should put that on the checklist for next time.
Right. Yeah. And it just didn't
go for Manny, the pin puller.
And is it confirmed that they did actually blow it up? I think somebody pushed the big self-destruct button. Yeah, I think so. Yeah, because it was just tumbling out of control. Yeah, it was spinning out of control. Once I saw it go past the single rotation, I went, on my live feed. I just went, Yeah.
That shot of from the bottom where you could see all the engines lit up, man. And they weren't all lit up.
No, there were 5 or 6 engines that were failed.
Cool.
Yeah.
Oh man.
Yeah.
That was so cool.
For those who don't know, it's twice the power of the Saturn V.
Yeah.
It's it's just insane. I just but yeah, it actually cleared the tower, and it worked. It was just the separation. It would have, if there's some.
I mean, there's also landing, right? I mean, there's it's supposed to, so both things are supposed to be able to come back and land themselves.
There's a lot still to do. There's a lot still to do. I can't believe that they weren't even going to attempt land-ins of these ones. It was always going to be totally expendable. They were just going to belly flop them in the ocean.
They were. Oh,
yeah.
Oh, I didn't know.
Even Starship was not supposed to propulsively land, even though that's one of its main jobs. So I can understand not testing it on the heavy booster because you just wanted to
That's
make
the last
sure
time
the
we got to
33
see these
engines
things
work.
blow up, right?
Right.
We got to see it all blow
Yes.
up when they were trying to do the self landing with the 3.
Yeah, exactly. But that's been just Starship. This is the first time the super heavy booster with the 33 Raptor freaking engines has, last time anyone has tried any scale of this sheer number of engines was the Soviet, none of this Russian rubbish, Soviet Union back then, the Soviet N1, and it didn't go that well.
Okay.
It had 30 engines. Had 30 engines. That was supposed to be their big moon rocket, and it just totally blew up. So, but 33 engines, but 5 or 6 of them didn't work, so it looks like they shut down.
Okay.
But I think if one of those blew up, then it would have started a chain reaction that blew them all up. That would have blown up the whole thing.
Yeah.
So, I don't know.
Yeah, I think it's pretty edge there.
It's pretty dicey. It's like, okay.
I have a new book recommendation. Maybe I haven't mentioned on the show yet. You knew this was going to happen. Delta V and Critical Mass. Those are both
right.
It's basically about asteroid mining and then moon mining, and I loved it. First off, because it's written by the same guy that wrote Damon and Freedom.
Yep.
So do you remember me talking about at DEF CON, the security conference?
Yeah.
They have like a hacking contest called Darknet.
Oh, I think so.
Yeah, so that's based on those early books on Damon and Freedom, right? So they basically built an entire like hacking contest based on those books, and it's just like this. It's just like this adrenaline ride. Both two books are
cool.
And then he wrote the space book and 2 space books, and friggin' fantastic. I hope he writes the third one. He kind of left it hanging for the third one, but so good.
Can I make a prediction?
Yeah, of the books.
Asteroid mining will not happen in my lifetime.
Oh, interesting.
So I'm talking I've got another good 30 years, hopefully.
Yeah, hopefully.
Right? Yeah. So it will not happen in my lifetime. That is my prediction. Because there's still so much stuff to mine here.
There's a lot of stuff.
Orders of magnitude. I don't know how many, 10 orders of magnitude easier and cheaper to simply mine it here.
Well, here's the thing. So this is what I had not ever thought about with these books, and this is why I liked them so much, is just like if you are able to mine in space, you would never actually. I always thought like when they, I remember someone talking about like the first asteroid miner, whoever owns the first asteroid mining company will be Earth's first trillionaire, and I think that could be true. But the thing I always thought that they were going to bring stuff back to Earth, right? Bring it back down the gravity well.
Yeah.
But there's no guarantee of that. Actually, the harder thing is to bring stuff from Earth up to orbit, right? Like the weight of doing that. So instead, if you have materials,
but the weight of getting heavy stuff back to Earth is, I don't know if it's just as bad, but it's very difficult to get heavy stuff back to Earth. This is why they had to leave their poop on the moon, right? they had to throw everything out the window, like they threw everything out the door, right?
But that's also because of the propellant to get back off that gravity well. So like. But what I'm saying is, I always thought that they would be putting...
also the incoming weight through the atmosphere as well.
Sure, no doubt about that. I'm just saying that I always thought that the point of asteroid mining was to bring more material back to Earth. But I had never considered the way that these books frame it, which is it stays in orbit, and then because it's so expensive to bring any material up from the Earth out to orbit,
they use it in space.
You can build stuff in space, right? I just, for some reason, my brain never made that switch over before, and then that is a large plot point.
With my prediction, I'm talking about bringing them back to Earth, right?
I see.
In my lifetime, I fully expect mining on the moon, right? So they mine oxygen, they mine water, right? They mine, they talk about the helium-3 or whatever it is. Stuff like that, right? No,
so
I can see that happening in my lifetime. Yep.
This talks about that,
but
kind of
everyone talking about mining gold from one of these asteroids and bringing it back. It's complete bullshit, right?
Yeah. No, right. I think the hard thing is actually like you think about like making propellant. It's like you need to split water off, and water. How about this? I should really say it like this. Many of the sci-fi novels that I read often talk about water being an important piece of propulsion, and that you need it to live, you need it to block radiation, and then you also need to split
oxygen.
It. So
one of the things that's being talked about, one of the primary things that they're planning right now for the moon, outpost is an oxygen pipeline from the mining facility to where they use the oxygen. right? Because oxygen's so important, right? You've got to mine oxygen. This is stuff that they're already planning and working on and actually developing as part of the Artemis space thing. It's one of the first things they're going to build when they get there is this oxygen pipeline so that you can transport the mined oxygen. So it's it's been all over the news in the last week or whatever, and that's one of the first things they're going to do when they get there. Is like because you can't have a colony without the mining, right? We can't send up all the
you need resources up there.
Yes, you need to mine the resources. So that is one of the first priorities. Yeah,
I never had that in my mind in any of this stuff. So yeah, that's
for
really
like Artemis 6 or something. That's for like the third, we'll send humans there. They'll do their little walkie things, right? And then
get the photo op.
And then only a few missions later, they'll be starting to build the mining type stuff. So cool. It's coming very quick.
Great. Well,
in the scheme of things,
if you like that kind of stuff in a high pressure environment, check out these 2 books. I'll link them in.
All right, cool. I will put them on my Kindle. I assume they're Kindleable.
Oh yeah. Oh, very Kindleable. Okay. Yeah. I bet you'll like them.
Cool bananas. All right.
Yeah, space, man.
Yep.
Never gets old. I still don't want to live out there though.
There's so much stuff happening at the moment. It's just nuts. Yeah. That's why there's 20 different space YouTube channels, and they've all got something new every week.
Exactly.
There's like new news, like literally every week. It's just crazy.
Yeah.
Something's always happening. But yeah. Starship. Wow, it actually got off the pad.
Yeah, it's great. Great.
Yeah.
I will watch every additional launch, to be honest.
Yes. Yeah. But catching, I still don't know about, the big...
the plucking it out of the air thing?
Hechazilla thing, the big Mechazilla arms that capture the super heavy booster. But they have to do that, right? To make it affordable to,
I don't get it. Yeah. I don't understand why that is, but...
Why? Well, because cost.
Why can't you just land it like the other ones? Why can't you just land it like the other ones?
Oh, okay, right. Okay, fair enough. I don't know the answer to that.
I thought it was just because it was cool and that it was hard to set them back up. But, if you're landing
maybe
and
something
it out
different
of the air,
with the super heavy booster as opposed to Starship. I don't know. Maybe the engines can't gimbal enough or something to...
Sure.
I don't know.
Yeah, could be. We'll find out.
Whew. Good stuff, though. Yep. Yeah. But damn it, the one little thing. Like, all it had to do was separate. Like, don't they have, like,
there's
explosive
things,
bolts which have been used forever in the space program? They're like 60 years and they never fail. Don't they use explosive bolts to separate the things? I mean,
No.
Just imagine, like, what's the new telescope? Can't believe I got a mental block.
James Webb Space Telescope.
James Webb Space
JSWT.
Telescope. Right?
Yeah.
That had over 200 things that had to happen in sequence for that thing to work.
Yeah, but that thing was put together over 25 years, and
it
that was NASA budget and NASA timelines.
But all they had to do was physically separate two items.
SpaceX budget and
physically separate two items.
That is not I don't think that's a
redundant
thing.
Explosive bolts.
Two massive things, though. Two massive.
Yeah,
things.
They're massive, but put a couple of explosive bolts in series, and
sure.
As long as you can blow one of them, the whole chain's going to go right. I don't know. Yeah, I'm just disappointed that I was saying it during the live stream. I went, right, I'm 95% confident that the rest of the mission is going to work because the separation. Like, I don't think anyone actually predicted, they're going to have a problem with the with the separation. That's just like, no. That's just nuts. Yeah. So, they're the most unlikely thing to failed.
Yeah.
Which is really remarkable. Anyway. There you go.
All right, let's move on to other remarkable things. National Instruments is getting subsumed. No?
Are they being bought, are they?
They're being bought, yeah. $8.2 billion.
Who's
by
buying
Emerson Electric.
Where's this in the list?
I don't know. 10, 15 down. Emerson Electric to buy National Instruments for $8.2 billion to deepen automation push.
Oh, yeah. I see it.
Here's the interesting thing. This is the most interesting thing to me, at least. At the last moment, our old friends, my old boss and our old friends, Papa Danaher, also known as Fortive, put in a competing bid at the same dollar amount
really?
at the last minute. And then National Instruments goes, nope, we're going with Emerson.
What? So they put in a higher bid?
Nope, put in the same bid.
Oh, the same bid. Okay, right.
Yeah, that's why I don't get that. Maybe it was like a little bit higher.
Well, they most likely had like a handshake deal with them or something, and they don't want.
I don't think that's how that works. No.
I don't know.
Handshake deal at $8.2 billion. You are a very trusting person. No,
but
many lawyers involved.
Like, especially if, like, they've kind of like, especially if come in with last minute, they had no clue. It's like, oh yeah, of course we're going to go with Emerson.
Right. Ford have also made a $60 per share offer, which is Emerson's offer, for National Instruments on Tuesday. But the seller decided to pick Emerson due to lesser risks in financing the deal and potentially easier path to regulatory approval. This is what I thought of. Basically, Ford owns Keithley, Fluke, and Tech. They don't own, obviously, but that's them trying to eat, a pretty, basically National Instruments has been eating a lot of the business of these other things in the test equipment space. I was going to ask,
how many companies have National Instruments actually, National Instruments or Semiconductor? Who are we talking about?
National Instruments. National Semiconductor was bought by TI
National Instruments.
15 years ago. Yeah.
Right, yes. Yeah. I was going to say, bloody hell, all this national stuff.
Yeah.
National Instruments, yes. How many companies have National Instruments actually gobbled up? Have they gobbled up any?
I don't know. I know I tried to work there and they rejected me hard.
Oh, hard rejection. Why?
Because I didn't have any experience. So this is when I was in Austin.
What job were you going for?
So I was in Austin. I was at Samsung. I was trying to I had an electrical engineering degree, but I had been working in a fab for 2 years. And I was like, I don't want to work in this fab anymore. Yeah. I would like to work in test equipment. And there's this awesome test equipment company in town. And they go, yeah, nah.
Yeah, nah. Okay.
Yeah, nah.
No.
So
there you go.
I mean, I knew people there even. They're like, no.
See, if you had built some hobby power supplies or something, you would have.
Yeah, that's what would have done it. Yeah, that's what would have done it.
Yeah.
Yep.
Mm.
Instead, I was out boozing in Austin. Yeah. Yeah, it's weird. I mean, like, they have kind of like this whole weird subculture too of like, so they have, I'm going to get this wrong. It's not Simulink. The MATLAB has Simulink. That is their control software. National Instruments has whatever the hell they call their automation software. So and they have like different divisions too, right?
LabVIEW.
LabVIEW. That's it. Test engineer here. Of course you would say that. You know this, right?
LabVIEW,
of course. And LabVIEW's got LabVIEW's huge, but like there's like the software control element of it all. And then they also build hardware for it as well, which is,
of course.
That's what was competing with all these hardware companies. So I'm guessing, if I had to guess, I'd guess the main reason that Emerson's buying them is the IP around I think the real moneymaker is the software stuff, because
but the software is so beautifully integrated with the hardware. It's magical, right? That's why people pay a premium for their stuff, is because the hardware, you pay a premium for their cards because it's integrated with their software, not only LabVIEW, but Windows CVI. So they've got like a C version of it, and it's just all integrated so beautifully.
When's the last time you used it?
Just
we
works.
should put that out there.
Well, I used it when I was at my old job, so we're talking 12 years ago now.
Yeah.
No, even further than that. Oh, geez, 15 years ago now. Holy crap.
Yeah, exactly.
Yeah, exactly. I didn't use it at Altium. Yeah. Oh, goodness. Okay. Yep. Oops. Yeah.
I mean, it's still well regarded. I know that, but like, not by the people that actually use it every day, but it's well regarded in the industry,
sure it hasn't
and it's
gone
very
to
standard.
Crap. I'm sure it hasn't gone to crap. It's just.
I was just always surprised they had like their own language. I think wasn't G a programming language?
I haven't heard of that.
Yeah, G programming language, mainly used in automation. It's a graphical programming language.
Oh, okay.
Used in LabVIEW. Yeah.
Maybe that's after my time.
Yeah.
Okay.
Yeah. Yeah, LabVIEW used, and it's like, but like then under the hood, it's like all this, it's all tied to other programming languages as well. So I think C under the hood or something like that.
Yep.
I never used it, but this is probably not going to impact many people, if I'm being honest, because Emerson's just trying to eat more of the market. They're not like gonna. I mean, they might change some things, but yeah.
All right.
Anywho, it's a company I don't know much about, apparently.
Okay, the other week, weren't you crapping on about a Prusa 3D printer?
Yeah.
So that's why I think unmanaged 615 has put it. I think he's trolling you somewhat, and it did get 7 thumbs up. No, sorry, no, I'm looking at the wrong thing. Anyway, he added this in, and there is a Prusa 3D printer issues, and you said, "Oh, it's so good that it just works," and apparently there's issues. Somebody's having issues with it. So,
yeah, I mean, okay,
yep, I think you're being trolled there.
Oh, maybe. I mean, I like the brand.
I highly recommend trolling Chris.
That's
by the way.
Oh, okay. Yeah, sure.
Yep.
Yeah, no one did take any photos of me at Embedded-World. I mean, they took photos with me, but they didn't take photos of me like you had asked. So,
yeah, boy. Yeah, there's actually some drama on I've seen on Twitter. Yeah, to do with Prusa and some RepRap festival or something. And there's someone on YouTube, I can't remember his name, who absolutely hates Prusa, and he was uninvited from actually having a booth at the 3D printer thing. So there's like lots of bad blood going on in the 3D printer community, apparently. Yeah, and it's all to do with Prusa. Some people claim that they're, and I don't know. It's anti-Prusa and pro-Prusa, and I don't know.
Who's got time? Like Who's got time, Dave?
Drama channels, yeah.
We got stuff to do. Like, I've been watching your stuff with I watched your enclosure video. I enjoyed that.
Okay.
I haven't watched these microcontrollers. You've been picking out microcontrollers?
I've been picking out microcontrollers. Just released another video this morning because all the three, speaking of fanboys, the STM32 fanboys came out of the woodwork, as I predicted in my first microcontroller video, that they would come out of the woodwork. Surely they did, and they said, I've picked the wrong microcontroller because I picked a microchip PIC 24F Jobby. Yeah. And they said, no, you got to use the STM ARM32L series, low power series. Chosen the wrong micro. So I did another video the other day, actually comparing the two, and there's some shenanigans going on in the ST datasheet. Let me tell you that for nothing.
Interesting.
Yeah, okay. they claim 88 microwatts per megahertz, right? Power consumption in active processing mode, because that's how you usually specify it. X amount of current, but
this is a battery powered thing you're making, yeah.
This is a battery powered thing. So power consumption is part of the equation. It's not critical. Like it isn't like a watch or anything that has to work for So it's not.
I'm always curious about those kind of readings too, like the power per megahertz, whatever. It feels like it's an antiquated thing where it's actually on the full bore kind of like you're going to operate at the top of its range, and it's really about like how much you're going to use at the top. Because I figure when you're in the bottom of the range, like most,
at least the things I do, product. Yeah, they're in sleep mode.
Yeah. But most of the things I do, it's like they're in sleep mode. They're just as off as they can be, unless there's a real time clock. And so it's just about like what is the draw.
You don't care how much power it draws when it's actually actively running for a few minutes. Yeah, exactly.
Right, exactly. Right. Yeah, it's like these spiky things, but and it does matter because it's about the efficiency of the processing, but it's not like.
Exactly.
I don't know. Okay. Anyway, so
that's why. Anyway, in my recent video, there's actually quite a few things involved here. In my recent video, I mentioned that a more accurate description is not the microamps per frequency. It's actually the microamps per MIPS, because you want to know how many instructions. Like if one processor is 1 MIPS at 1 meg. Right, so it's processed with 1 instruction per cycle, and another one's 1 instruction per 4 cycles. Then that's 1/4 the processing power for the same current per megahertz. And then you can say, well, current shouldn't. You shouldn't use current. You should use power. So it should be microwatts per megahertz or microwatts per MIPS. So there's like 3 or 4 different ways that you can categorize this. And I think technically it's power per MIPS is the best way to do it. But the data sheets never give you that figure, because a lot of, including the STM32, they actually run the core at 1.2 volts, right? So they've got a built-in low dropout regulator, and also I think there's some versions of it that have a built-in DC to DC converter. So if you're using a DC to DC converter, an external DC to DC converter, then you're talking about constant power consumption, whereas an LDO is a linear regulator, so it's constant current. And and constant current into your load, and they're two very different power consumption ways to consider power consumption in your load, because the DC to DC converter constant power is going to be more accurate than your constant current, which will change with battery voltage as your battery voltage drops, right? So your power consumption is going to drop as your battery voltage drops, right? So it's all this weird, there's so many different ways to look at power consumption of a microcontroller. It's crazy. And it's almost impossible to compare. As I said in the video, really the only way to genuinely compare two micros is to actually build them up.
Make two boards.
Yep. Make two different boards, run the same software on both, and and physically, turn on all the peripherals, go into all the sleep modes you want to go into, and it's just
How much is this something that actually matters for your product, or is this something that you're kind of just honing in on?
That's what my video was about, is that it doesn't really matter. And I mentioned this the video, is that I'm powering it from a pair of AA batteries, most likely. I haven't got the exact final form factor yet. But I did the worst case calculation. Even if the thing was on 24 hours a day, 7 days a week, 365 days a year, it's still going to have 2 years battery life.
Oh, wow.
Worst case, right?
Yeah,
so it's like, so it's like, it really doesn't matter, right?
Yeah.
So it doesn't matter that the STM32 was half the power of the PIC. Like it made no difference, really.
So I was back on the Embedded podcast, and I mentioned to them that like past me felt bad for current me because like past me didn't care about like really. I think one of the things when like in this environment is like, what is the speed to implementation, right? It's like you could go and find the lowest power thing out there, but if it's got like a crappy software support and like you have to do all the bit twiddling yourself to access the registers versus like using some abstracted interface that's just gonna like be done. It's like just pay the extra, do the don't optimize at the beginning unless you really need to.
Unless you really need to. That's what I mentioned. Unless you're really on the bleeding edge of your product, and it's absolutely critical. It makes or breaks your product that you have to use this micro because of cost or power reasons. Right. Then you just choose the one that's easiest to implement. Yeah.
And I mean, you've had PIC products in the past as well. So you know the ecosystem, you like it. Like that's more than enough in my mind.
Totally. And then once I saw in my first video, I saw that because mine's going to have a custom LCD in it. Right. And it's going to do some blinking of the LCD, right? Sure. And it's got built-in blinking and animation modes for the LCD that don't use the core at all. So it's built in. Cool. So if you want to toggle between two different things on the LCD, you can do that. And you can do that in complete sleep mode and not even power up your core at all to do that. It's done in the LCD engine. It's great.
Cool.
Right.
That's great.
That's a really cool little feature.
Even if you couldn't do that, even if you didn't have I just mean like, I said like on the other show, like my specsmanship in the past, like mine, like, oh, I need to have this and have that. Like that can often be outdone by like comfort with a platform, I think. I could just go write something or put down another part, whatever. Like
a really classic case of this, if you're a subcontractor like Mike Harrison, for example, right, who we've had on the show, right? He does, all these LED lighting systems that he does. He just uses PIC32 for everything. Because that's the tool, like he has all the routines, he has all the tools down pat, and he can implement a new product in days, right?
Yep.
Because he has all the existing tools in place. So unless he has some absolutely overriding, I've never heard him use anything other than a PIC32.
Yeah.
I don't think anyway. Because it's just, rarely does he, he just never comes across a situation where, the PIC32 wasn't suitable.
Right.
He isn't talking millions of volumes, so he's not trying to save cents, right? Yep. And he's not doing ultra low power stuff, so he's not considering every microamp probably.
I think the other thing too is that when people start thinking like, oh, I have this new function that I have to do, and it's like there is a wide, so like just from my life example of my work example rather, of like if you're adding connectivity to something, like there are so many integrated parts that you could say, oh, you should switch to this thing where there's like a micro plus that communication method that's in there now. Yeah. And it's like, yes, you can do that, but there are umpteen options to go and add the connectivity as a peripheral as well, right? So that you could still have your main processing and then offload it through a separate AT modem, or something like that, right? It's
of course.
It might not be the most optimized, but if it's going to speed up your production, it's probably worth it for at least your prototype.
Yeah, totally. Yeah. So, I don't know. I could end up using a different micro than the PIC 24F. I don't know. But at this stage, there was no compelling. My latest video said, no, sorry, I don't see any compelling reason to go for the STM32 over the PIC. Yeah.
Go change it in Rev 2 if you really need to, you know?
Oh, yeah. Yeah.
It sounds like it's pretty straightforward.
It's a pretty simple product. Yeah. It needs some 32-bit timers. It needs some custom LCD drivers and not much else.
Yeah, that's great.
You know.
Cool. Well, good luck, man. That sounds like a fun.
Yeah. I'm sure there's half a dozen micros on the market that could do this job. You know.
Oh, I'd say more than that probably. Unless you really need that integrated LCD piece, then.
Or I wanted ultra low cost, like because the PIC is $2 something. If I wanted something that's in the, sub dollar or something like that. It's in the cents range, right? Then I'd be going for some obscure Asian, I'd be going for some Holtec or something that's available on. Yep.
Speaking of processors, I don't think we mentioned this last week, and it wasn't out a couple weeks ago, but I was pleasantly surprised to see one of my favorite companies, which is Nordic Semiconductor. They have a new part that just came out, dual core M33. That's no different than before. What is different though, Dave? Multiple RISC-V coprocessors.
Oh,
that's the first I've seen. That is one of the biggest chip companies I've seen. They're not the biggest, right? But that is one of the biggest chip companies I've seen that's adding RISC-V into a banner level product like this. And they still haven't said what are they for, but
yeah, right.
I'm guessing,
if you build it, they will come, right?
Yeah, I think so. Well, yeah, I mean, they build Bluetooth. So this is going to be the thing that's in tons of, headsets and
but then you need two different tool chains for the one chip.
It's all Zephyr, man.
Right. Okay.
So, I mean, honestly, right. They have different targets within there.
Yeah.
But yeah, it's all going to be using the stuff under the hood that you have to worry about it.
Right.
You have to worry about other things with Zephyr, of course, but
okay.
But yeah.
Cool bananas.
Yeah, that is interesting. I don't know. It's the seeing what that is. They have a weird new. It's so there's NRF54H20. That's the new thing, and then a bunch of memory too, beefing up memory. So will be interesting. I remember I had gotten excited because I saw. I saw one of their job listings on LinkedIn 6+ months ago, and they were advertising a RISC-V. I think I maybe mentioned on the show, but they were advertising a RISC-V engineer, or something that had experience with it.
As in a chip level.
Mm-hmm. Yeah.
Right.
Yeah, someone who worked with the standard, has built stuff for it. They haven't announced what the cores yet are either, right? It's an instruction set architecture, which is RISC-V, but
fire alarm.
Well, I guess the show's over.
I guess the show's over. Okay.
All right, we made it. All right.
I don't know if you can hear that in the background.
I can. Oh, definitely. Yeah. All right.
All right.
Be safe.
I'm out of here.
We'll catch you on the next show.
Catch you next time.